Okay, hi, this is Test 2 review for Calc 1. You'll be taking it through Proctor U, so I hope you've already made or scheduled your time to take the test during what will be next week for me. I don't know when you're watching this, but hopefully you've already made reservations for your time. So it'll be in you'll go to the Proctor U, but then they're going to have you log into once the test time comes, they'll say to you to log into WebAssign, and then you'll click on the Math 1610 test 2, and then they have to type in the password, I believe, and then you go ahead and take the test. The test is 30 questions long. I believe you have, let's see how long you have for this. Does it say? So view settings. It looks like you get 2 chances for each question. Anything else? No template used. I'm looking for the time. How long do I have? Okay, sorry. I didn't mean for this to take an hour. Maybe if I go view, it'll say how long I have. Of course not. Hey, that's so helpful. Thank you. I believe you have 2 hours to take it. It'll say. Sorry. View settings. I can't believe it doesn't say how long I put it for. How annoying. Okay, I'm sorry. Anyways, let's get to the review. I gave you a pool of questions. Basically, you can find similar questions in the book, or you can go into WebAssign and find similar questions. For example, 3.1, 77 to 80, anything like that. Those, if you look in 3.1, if you're using WebAssign, you'll be able to tell which questions are 77 to 80 from the book by kind of looking at this little number. I think it's the number right here after it says LAR Calc ET7 3.1.015. That's question 15 in 3.1. Okay, so questions like 77 to whatever 80 are. I'm looking for them. Okay, so here's 77 right here. And what these do are ask whether or not the function is differentiable. And the main types of problems they look at for differentiability, well, maybe it's better to think of when it's not differentiable, right? So in the picture you're looking at to the right, it's not differentiable at what they call a cusp. So where it's not smooth, there's this corner right here at -5. So not differentiable at, so this is problem 77, at -5. So they want you to write kind of where it is differentiable in interval notation. You'll just go -infinity to -5, union with -5 to infinity. Okay. If you don't know why it's not differentiable, you can always, at this point, we can take the derivative of that function, right? So f prime of x would be 2/3 times x plus 5 to the -2, 2/3 minus 1/3 minus 3/3 is minus 1/3. And the expression is 2 all over 3 times x plus 5 to the 1/3. Okay, so this thing, the derivative is, you can literally think of it as like a function, and where does it have an issue? Well, at -5. In particular, if we have x equaling -5, you'll have division by 0. Okay, so not just graphically, but algebraically, we can make a conclusion about the differentiability just by looking at the derivative at this point. Okay, another one is if you have in this problem, this is number 78. If you have infinite sort of discontinuity, in other words, you have a vertical asymptote. Okay, so it won't be differentiable at those places. So in particular, in this case, if you look at the graph real closely, it's -8 and x equals 8, where you have those asymptotes. Everywhere else, it's good. And again, you could literally take the derivative and find where it's not continuous, and that'll kind of give you the same answer. Okay, or find the domain of the derivative. That will give you the same answer. Okay, let's get another one. This one's a little weirder. This number 79. You may think that it should be differentiable at -4, but if you think in terms of left and right derivatives, there's no derivative coming in from the left, and the left and the right derivative have to be the same. Not only that, furthermore, I believe that the tangent line goes vertical at this point right here. So those two issues force it to only to be differentiable on the interval from -4 to infinity. So you don't include -4. And again, this one is not differentiable at its cusp. Okay, so whenever it has a corner on it, it's not going to be differentiable. So that's like 81. Not differentiable at x equals, I guess that would be 8, right? So the differentiable interval would be -infinity to 8, and then union with 8 to infinity. Okay. For 78, the interval on which it's differentiable would be then -infinity to -8, union with -8 to 8, a union with 8 to infinity. Okay. Okay. So I think probably you got about the same types of problems in the book. So whether you use the book or kind of just look at your WebAssign questions, you'll probably come out okay. Let's look at 3.2 type problems, and I'm going to be picking problems similar to 7 to 57 odd, and then there'll probably be one application similar to question 101, which is on dropping a projectile of some sort of silver dollar in our case. So you can go through and kind of, here's problem 13, you try that and see how it goes. So if we have number 13, y equals the 8th root of x. Okay. So the way we're going to do these is by converting it into x to the 1/8. Convert it into a rational exponent, and then this is a power rule. So you bring down the 1/8, and then you have x to the 1/8 minus 8/8, which is minus 7/8. Okay. And usually they don't want the negative exponent, so you could rewrite it 1/8x to the 7/8, and you should be good. Okay, so you need to know the power rule. You're going to need to know how to work with exponents. You're going to need to know the derivatives of the trig functions. You need to know the derivative of e to the x. Let's look at this guy. This is number 26. So I have y equals 3/7 e to the x plus 8 cosine x. Okay, so y prime, constant multiple rule says leave 3/7 alone. Then we have the derivative of e to the x is e to the x. And then the derivative of cosine is negative sine x. Okay. And then clean it up a bit. Okay. Let's see what else. So like up to 57. Let's try this guy. T squared. So this is 43. G of t equals t squared minus 8 over t cubed. Okay, so again, rewrite these to take advantage of the power rules. So t squared minus 8, t to the negative 3. And so g prime of t will have 2t to the 2 minus 1, which is just 1, minus 8 times the derivative of t to the negative 3. So that would be negative 3t to the negative 4. Simplify. This will be plus 24t to the negative 4. And I don't know if WebAssign allows you to write it in with negative exponents, but you can get rid of the negative exponent by dropping it to the denominator. So you get plus 24 all over t to the 4th. Okay. So up to 57, I said. So let's try 54. Okay. Again, this is just a matter of rewriting with exponents and taking advantage of the power rule. So I'll have 8 all over the cube root of x plus 9 cosine x. F prime of x then, rewrite, well, I'm going to rewrite this first, so let me not write f prime. F of x then is 8x to the negative 1/3 plus 9 cosine x. Okay. And then take the derivative. So f prime of x will be, leave the 8 alone, then we bring down the negative 1/3, x to the negative 1/3 minus 3/3, minus 1, you know, is the same as minus 3/3. So you end up with negative 4/3. Okay. And then plus 9 times the derivative of cosine is negative sine. Clean her up. So I'm getting negative 8/3 x to the negative 4/3 minus 9 sine x. And then if you want to get rid of the exponent, the negative in the exponent, it'll be negative 3 all over x, and you change the sign of the exponent to positive. Okay? So just go through there, either use WebAssign to redo problems or go into the book. I think the problem with WebAssign is like if you redo it and you get it wrong, I'm hoping you don't like miss points because of that. So it might be easier just to go into the book and find problems there and work them out that way. Let's look at, I think so this is 3.2 we're in right now. What are we in? Yeah, no. Well, I should have wrote 3.2 here, I'm sorry. Okay, so 3.2 on the 57. Let's look at 101. Do they even have 101 in here? Yeah. Okay. So this is one of the story problems that's kind of about physics, projectile motion. And let's take a look. So determine the position and velocity functions for the coin. So a dollar is dropped at the top of the building that's 1,384 feet tall. Use position function for free falling objects, which is given as s of t equals negative 16t squared plus v sub 0 plus s sub 0. Okay. V sub 0 t plus s sub 0. So the velocity, if you're dropping it, is going to be initially 0, and then the initial position is just the height of the building you're standing on, so it's 1384. So our position function s of t will be negative 16t squared plus 0t, so plus 0, and then plus 1384. Okay. And I think that's the first question they ask for. Determine, yeah, and then the velocity, you just find that by taking the derivative. So v of t will be negative 16 times 2t plus 0, so negative 32t. Okay. So that's like part A, I think. Part B. Find the average velocity on the interval from 3 to 4. So what you're going to do is just take s of 4, the endpoint, and then minus s of 3 all over 4 minus 3. Okay, so average velocity is just a slope of the secant line between those 2 points. So plugging 4 into that formula, we get negative 16 times 16 plus 1384 minus negative 16 times 3 squared is 9 plus 1384. Sorry, I'm having to smush that. And then divided by 1. 4 minus 3 is just 1. Okay. And then we may need a calculator. So 16 times 16 is 256. Negative 256 plus 1384. Plus 16 times 9. I have like the worst calculator in the world right now. My nice fancy TI calculator is not working for whatever reason. It's all over 1. 1384s go away. negative 256 plus 144, negative 112, and feet per second. Okay, find the instantaneous velocities. So for instantaneous velocity, you're actually working now with the derivative. Okay, so we want to know in particular v of 3 and v of 4, I believe. So all you're doing is plugging numbers into our v formula, which is negative 32t. So v of 3 is negative 32 times t, which in this case is 3, so you get negative 96. And then v of 4 is negative 32 times 4, which will be negative 128. Okay. Find the time required for the coin to hit the ground. Okay, so we want to know the time when the position is 0. Okay, so in the position function, put 0 in for s, and then solve for t. Okay, so we'll have 0 equals negative 16t squared plus, I forget what it was, 384. Okay, so solve for t. Divide both sides by 16. Is 86.5. Jeez. And then take the square root on both sides, whatever that is. They want 3 decimals. Okay. So the square root of that, so the square root of 86.5 is 9.301 seconds, basically. Find the velocity of the coin at impact. Okay, so now you just take that number and plug it into your velocity formula. 301. So that's going to be negative 32 times 9.301. 32 times 9.301. And that's negative 296, or negative 297, and they want 3 decimals, 0.632. Okay. Okay. I think that's probably the only story problem I put on the test. It's mainly just, do you know how to do your derivatives? Okay. Okay, so with derivatives in mind, then we move to 3.3 now. And in 3.3, you get the product rule and the quotient rule. Okay, so you definitely have to know the product and the quotient rule. Okay, there's no way around it. Oops, I wrote that wrong. Let me erase that. So 3.3, we're looking at problems like 5 to 29 odd, and then 43 to 51 odd. Okay, so let's go in there, take a look. It's 3.3 we said. Okay, so again, 5 to 29 odd, so anything like that. Let's try number 4. But this is number 16. Okay. 16. The thing is cosine t over t to the 7th. Okay, this is a quotient rule. When you have a fraction like that, usually it's a quotient rule, unless you can reduce it, and of course in this case we can't. Okay, so f prime of t is going to be low d high minus high d low all over the low squared. Okay. Okay, so what do we got? Negative t to the 7th sine t minus 7t to the 6th cosine t all over t to the 14th. I don't know if they'll let you type it in like that, but you can factor out a t to the 6, it looks like. You have negative t sine t minus 7 cosine t all over t to the 14th. So in real life, you're going to want to simplify because the problems will build off of these problems. So when you get the Calc 3, maybe this, just finding the derivative would be part of the work. And you would have to do something more with the derivative once you get done. Or maybe in your engineering classes, you'd have to do more with the derivative once you're done. And to work with the derivative, you want to have it as simple as possible. So just keep that in mind. So t to the 8th. Okay. Let's look at another one. Hopefully a product rule somewhere. Okay. This guy looks like a quotient rule, but it's not. Right. It's kind of a trick question. So they're hoping, well, I know they're not hoping, but they're afraid you're going to do the quotient rule on this thing. So we have x cubed plus 12x all over 3. You don't want to, right? You want to butterfly it, so that's the reverse of finding a common denominator. So you'll have x cubed all over 3 plus 12x over 3. Then you can reduce that, so it's 1/3 x cubed plus 4x, and then take the derivative. So don't use the quotient rule unless you have to, because it's more complicated, there's more probability of error. Okay, so the derivative then, leave the 1/3 alone, this will be 3x squared, and then plus 4. So you're going to have x squared plus 4. Okay. Yeah. Okay. I was looking for a product rule. Hoping for a product rule. That's one where you want to simplify again. This is a quotient rule. Product rule. I need a product rule. Gee whiz. Maybe I got to go all the way back to the beginning here. That's even a quotient rule. Geez, were there no product rule questions? Well, there will be product rule questions on the test. I guarantee it, and you will see them in the future. Let's try number 9. Okay, so I have f of x equals 8e to the x cosine x. Okay, so the product rule, you leave one factor alone. So I'll leave 8e to the ex alone and take the derivative of the other. And then you reverse it, right? Now I'm going to take the derivative of the first. So the derivative of 8e to the x is 8e to the x. And then you leave the second factor alone. So cosine x. Some people say it's 1d2 plus 2d1 is one way to remember it. That's the product rule. Okay, clean it up so you can factor out an e to the x if you wanted to. I'm just going to leave it like that. I'll have negative 8e to the x sine x plus 8e to the x cosine x. Okay, so product rule, make sure you can do the product rule. Definitely not going to go anywhere anytime soon. Okay. I feel like we should do another quotient rule. Sure, let's do number 12 here. So we have f of x equals 8x minus 11 all over the square root of x. And you could butterfly it and then just do the derivative there. Let's do the quotient rule though, so we get a nice answer. So f prime is going to be low, x to the 1/2, d high, which will be 8, minus high, 8x minus 11, times the derivative of the low. So that would be 1/2 x to the negative 1/2, okay, all over the low squared. So x to the 1/2 squared. Okay, start cleaning it up. So I'll have 8x to the 1/2 minus, and I'm going to rewrite this thing with a fraction. So I'll have 8x minus 11 all over 2x to the positive 1/2. Down below, you multiply the exponents. 2 times 1/2 is 1, so I'll just have x. Okay. In math, we hate complex fractions, so we're going to multiply top and bottom by 2x to the 1/2. Okay. And the numerator, when I distribute that thing to the first term, we'll have 16x to the 1/2 plus 1/2 is 1. Okay. And then when I distribute to the second term, it'll cancel with the denominator. So you'll just have minus 8x minus 11, and then all over 2x, and you add the exponents, because this is the product rule for exponents. So 2/2 plus 1/2 is 3/2. Okay? And we're slowly converging to the answer. 16x minus 8x plus 11 all over 2x to the 3/2. And of course, that'll just be 8x plus 11 all over 2x to the 3/2. Okay. Of course, with the quotient rule, then we get all the other trig derivatives, and you should know the 6 trig derivatives. You should have those memorized. Make a note card or something. I don't care what you got to do. Get them memorized. Okay. So, for example, number 17, or it'll be number 55 in the book. Okay. Oh, yay, we get a product rule. X squared tan x. So f prime of x will be, leave the first term alone, take the derivative of the second, that's secant squared x, plus take the derivative of the first and leave the other guy alone. Okay, there it is. Let's see if there's anything. I was wondering if the logarithms were in here. Did we do the logarithms in this section? Well, we only go up to, I only have problems up to 51 anyways, so we're not going to be looking at those. I just went up to 51. Sure, we could try that if you want. So this is number 51 and 3.3. We have y equals 9 times 1 minus sine x all over 2 cosine x. There's 2 ways to approach this. You could factor out the 9/2, kind of like rewrite it as 9/2 times 1 minus sine x over cosine x. And then you could simplify that, okay, to turn it into like secants and tans and stuff. So this would be 9/2. And again, you're butterflying. Okay, so 1 over cosine, you know from trig, hopefully, is, do I know it? Yeah, no, I do. Secant x, and then minus sine x over cosine x is tan x. And then you can take the derivative pretty easily using the constant multiple rule, and so if you redistribute the 9/2, we get this, and then go ahead and take the derivatives using your memorized derivatives. So this would be then 9/2 secant x tan x minus 9/2 times the derivative of tan, and then is secant squared x. Okay. Okay, so yeah, got to have those derivatives memorized. Let's move on to 3.4, which is basically all the same stuff, but now they're going to include the chain rule. Okay, so 3.4, I'm looking at problems like 13 to 49 odd, and then 57 to 89 odd. Okay, so let's cruise on up. Let's see what we got. 3.4. I'm going to go back in here. 3.4. Okay, so 13 to 49. Let's just pick one. Pick number 18, I guess. Okay, so I gave you 2 ways to approach these problems. You can kind of do substitution method, or just think of it in terms of the outer part and the guts, right? If you do the substitution method, you're kind of, you first identify the shell part. So you'd have, well, actually, the way I did it is inside out, right? So you start with the inner part, and usually that's just going to be the stuff if you rewrote this in parentheses. So 9x squared plus 8. And my physics teacher used to call that the guts, right? So the inner part, u, is 9x squared plus 8. And then the outer part, y, is just going to be u to the 1/3. Okay? And then to find the derivative, you just take the derivative of y and times it by the derivative of u, okay? Which is just the outer part times the derivative of the guts. So the derivative of y will be 1/3 u to the 1/3 minus 3/3, which is minus 2/3. And then times the derivative of u, which would be 18x. Okay? And then we want to back substitute. So what do we have? 18/3 x times u, which is 9x squared plus 8 to the negative 2/3. And then let's clean it up. 18/3 is 6, so we have a 6x, and then we can drop the rest to the denominator. Okay, so that's one way to attack these problems. The other way is kind of maybe simpler once you get the handle on it, but it could be harder if you have like triply composite functions, like two functions inside of each other inside of another function, right? Those are a little harder, and you probably want to do like a substitution type there. Anyways, let's look at this guy. This is number 21. And we have 7 all over s cubed minus 8 to the 3rd power. Okay, so first I'm going to rewrite this thing. And I'm going to do it the other way that I kind of taught you. So first the constant multiple rule, leave the 7 alone, and then times the derivative of this thing. Okay? So you take the derivative of just the outside part, so you bring down the -3, and then you leave the insides alone, and then -3 minus 1 is -4, and then take the derivative of the guts and tack that on, so it would be 3s squared. Okay, and then you clean it up. So 3 times -3 is -9 times 7 is going to be 63 negative all over s cubed minus 8 now to the 4th power. Okay. Whoop, I lost my s squared. So take your time, don't be like me and be rushing through it and get wrong problems. So get another. Okay, so this guy is a little harder because it's a product rule on top of the chain rule. So let's look at that. This is 26. We have y equals x squared. Let's try x squared times the square root of 49 minus x squared. Okay, I'm going to rewrite it. Okay, so first leave x squared alone, and then I'll take the derivative of this part. Okay, so I'm going to bring down the 1/2. 49 minus x squared to the 1/2 minus 1 is -1/2, and then times the derivative of the guts. Okay, so that would be -2x. And then plus, now you take the derivative of the first term. Okay, so that's 2x, and you leave the second term alone, times 49 minus x squared to the 1/2. Okay. You clean it up. So what do we have? -2 times 1/2 is -1, so I have -x cubed all over the square root of 49 minus x squared, and then plus 2x times the square root of 49 minus x squared. You could simplify this if you want. I don't know if it's necessary, but you'll need a common denominator, so you need to multiply this top and bottom by 49 minus x squared. Okay. So this would be, let's see, -x cubed plus then 2x times 49 minus x squared. Okay, so this times this, the radical will go away. And then that's all over the common denominator, 49 minus x squared. Okay, so this will be -x cubed plus 98x minus 2x cubed over the square root of 49 minus x squared, which should equal -3x cubed plus 98x all over the square root of 49 minus x squared. And then, definitely that's good enough. But I would probably just write it as I originally had it, like this, without all this baloney. Okay. Without the 1, obviously, you don't want to write this as a fraction. That's silly. Okay. Let's see what else we got. Okay, so that was a chain rule with a product rule. you definitely want to be able to pull off a chain rule with a quotient rule. So let's try one of those. Looks like number 27. Y equals 8x all over the square root of x squared plus 8. Definitely want to be able to master this one. Let's rewrite it first. And then it's low d high minus high d low. Okay, so low x squared plus 8 to the 1/2 times the derivative of the high minus high times the derivative of the low. 1/2 times x squared plus 8. 1/2 minus 1 is negative 1/2, and then I have to tack on the derivative of the guts. So there's the chain rule for you. All over the bottom squared. And you need to simplify that. You cannot work with that. Okay, so let's clean it up first. X squared plus 8 to the 1/2 minus the 2's will cancel with the 1/2. You have x times x is x squared. And then I'm going to drop that negative exponent to the denominator and make it positive. And that's all over x squared plus 8. Multiply the exponents here. 2 times 1/2 is 1, so you just get x squared plus 8 to the 1. Then I want to get rid of the complex fractions, right? So you're going to multiply by that denominator that you see in that second term here. Okay? Multiply by the x squared plus 8 to the 1/2, and that'll take care of it. Okay. So in the numerator, this times this, you have like bases, add the exponents. So you have 8 times x squared plus 8 to the 1/2 plus 1/2, which is 1, minus this times this, the denominator will cancel with that term. So you'll just have x squared. And downstairs, you'll have x squared plus 8 to the 1 plus 1/2. So 3/3 plus 2 halves plus 1/2 is 3/2. And it should turn out pretty nice in the end. So we have 8x squared plus 64 minus x squared all over x. Whoops. I know that's not right because there should be that 8 right there because I know it works out kind of nice. So you can cheat a little because you know this is probably going to work out kind of nice. So usually, okay. So x squared plus 8 to the 3/2. And then these will cancel out each other. You just end up with 64 all over x squared plus 8 to the 3/2, and then you're done. Okay. But seriously, folks, that one's important. It will be on the test in some form. 43 to 51. Maybe this is where we start getting the logarithm problems. Is it? Oh, that's secant. Let's try some trig ones while we're here. So this is 45, and we have f of t equals 8 secant to the 9th times pi t minus 8. Okay, so this is kind of one of those triple composites I was talking about. If you rewrite it, it's 8 times secant of pi minus 8 raised to the 9th. Okay, so there's this inner part right here, and then there's this inner part here, and then finally you have the outer part. So there's 3 things there. So let's call the inner part u. That's it should be pi t minus 8. I apologize, pi t. Let me smush that in. So the inner part is pi t minus 8, and I did it again, pi t minus 8. And then the next level out, we'll call that, I don't know, z. That's secant of u. And then the next level out, we'll call the y. And then that's just going to be 8z to the 9th. Okay, so that's a 9. Okay, and then for the derivative, you just go straight across and multiply them. So you get your derivative, I guess it's called f prime of t here. 9, bring down the 9, so 8 times 9 is 72z to the 8th. Times the derivative of secant u, which is secant u tan u, times the derivative of u, which will just be pi. Okay, then we need to start back subbing, right? So first I'll back sub the z, so I'll have secant u to the 8th times secant u times tan u times pi. I'm going to move that pi up front, right? You want all the constants up front. So I have 72 pi, and now I need to back substitute the u expression. So I have, but you can multiply out these secants if you want to first. Secant u to the 9th times tan u, because you have 8 secants here and then 1 secant here. Add the exponents. 8 plus 1 gives you the 9. And then, yeah, tan u. And then you go ahead and back substitute the u expression. So you'd have secant to the 9th of pi t minus 8, and then tan of u, which is, again, pi t minus 8. Okay. I don't know if I put any that hard on there. Let's try this one. Number 48. Okay. Y equals cosine of 8x plus cosecant of x. Okay, this one's a little easier. There's really only one composition here. It's the inner part in the parentheses of 8x plus cosecant x, and then the outer part, y equals cosine of u. Okay, so it really is just those two pieces, even though it looks more complicated. So y prime is negative sine of u times the derivative of u, which is going to be 8 minus cosecant x cotan x. Back subbing in u, this will be sine of 8x plus cosecant x, and then times 8 minus cosecant x cotan x, and then that would be your answer. Okay. Let's move on to the next section. I think that's good enough. What was that? Number 48. Well, no, we got to look at 57 to 89. Those kind of problems. 57 to 89. So pretty much anything in here. Those must be logarithms and exponentials. I'd rather not do that one right now. Okay, so remember the derivative of a logarithm. If you have ln of u, the derivative with respect to u will just be 1 all over u times the derivative of u with respect to x. So for number, what do we got, 74? I got h of x is ln of 8x squared plus 7, and then h prime of x will just be 1 all over the guts, 8x squared plus 7, times the derivative of the guts. So the derivative of 8x squared will be 16x. Derivative of 7 is just 0. And then we can simplify it, or make it look pretty, with 16x all over 8x squared plus 7. Sure, let's do that guy. Okay, so this is number 62. We have g of t equals e to the negative 8 all over t to the 8th. So g prime of t. With exponentials, you'll get back the same exact thing. And then you have to multiply by the derivative of the exponent. Okay? It's not the power rule. You can't bring down the negative 8 over t to the 8th and just subtract 1. It won't work. Okay, let's rewrite it so the derivative is a bit easier to figure out. So the negative exponent there. So we'll have negative 8 times the derivative of t to the negative 8 will be negative 8 t to the negative 9. Okay, so we get 64 t to the negative 9 times e to the negative 8 over t to the 8th, which you can then rewrite if you wish. Well, you don't even have to rewrite it. I'm looking at the answer they got, and they didn't even bother. If you're worried about 66, sure, let's do that. Y equals, it's really not a big deal. E to the x minus e to the negative x over 8. That thing looks like a hyperbolic function. You'll learn about those later. They're exponential functions that kind of have the same behavior with respect to derivatives as the trig functions. So if you learn all the trig derivatives, figuring out the hyperbolic derivatives aren't that big of a deal. But anyways, let's go ahead and find its derivative. I'm gonna butterfly it, so have 1/8 e to the x minus 1/8 e to the negative x. Okay. So y prime is 1/8 e to the x. The derivative of e to the x is just e to the x. And then minus constant multiple rule, leave 1/8 alone, and then the derivative of e to the negative x. That's going to be e to the negative x times the derivative of its exponent. Okay, so the derivative of negative x is just negative 1. And you can rewrite it 1/8 e to the x plus 1/8 e to the negative x. Or if you'd rather, e to the x plus e to the negative x all over 8. Okay. Okay, is that good enough for now? Yeah, I think we'll be all right. Sure, let's move on for now. So where are we currently? We were in 3.4 maybe? Geez, we did a lot already. Okay, yes, 3.4. So I want to move to 3.5, and in this section you're looking at problems like 5 to 25 odd, and then 69 to 73 odd. And I have a feeling these are the implicit differentiation problems. Okay, so let me look. So 5 to 25, let's look at 10. Let's see what we got going on. Yeah, implicit differentiation. So let's take a look. So I have 9x squared y plus 8y squared x equals negative 9. Okay, so all you're doing is tacking on a derivative of y with respect to x whenever you take the derivative of y. Okay? You follow all the other same rules. So if you have a product of functions that are dependent on x, you're going to have to do a product rule. So for example, in this guy, you'll first leave 9x squared alone, take the derivative of y, then reverse it, right? Okay, so we have 9x squared, and then times the derivative of y, which is 1. Because you took the derivative of y, you have to tack on the y prime. And then plus, now you take the derivative of 9x squared. So that would be 18x, and then leave y alone. Okay, plus, this guy's the same deal, right? It's also a product. So I have leave 8y squared alone. The derivative of x is just 1. And then plus, the derivative of 8y squared will be 16y times the derivative of y, and leave x alone. And then on the other side, the derivative of negative 9 is 0. Okay, let's clean it up. Squared y prime plus 18xy plus 8y squared plus 16xy y prime equals 0. We need to collect the y prime terms together. So 9x squared y prime plus 16xy y prime, and then move the other guys to the other side, negative 18xy minus 8y squared. Factor out the y prime. So we got 9x squared plus 16xy negative 18xy minus 8y squared. Divide both sides. And you should have your answer. So y prime is negative 18xy minus 8y squared all over 9x squared plus 16xy. Okay. Let's see if we can find like a trig version of this issue. There's a cotan. Oh, this one. Okay. I put this one on the test last year. A lot of people had trouble with it. It's number 21. We have y equals sine of xy. Okay, so y prime equals cosine of xy, and then it's a chain rule. So then times the derivative of xy. And there you got to use a product rule. So leave x alone times the derivative of y, which is 1. Then you have to tack on y prime. Plus the derivative of x is 1 times leave y alone. So you have y prime is, let's clean it up a bit. distribute. Collect all the y primes together. Factor out the y prime. And then lastly, divide. Okay. So y prime will equal y cosine of xy all over 1 minus x cosine of xy. Okay. Okay, I think there's also logarithmic differentiation in this section. So 69 to 73 will probably be those kinds of problems. Let's look at 18. Ooh, that was a nightmare. All right, so we get, what is it? What did I say? That was 72. Okay, so the deal with these, you want to take advantage of the properties of logarithms. Okay, and you start by taking the log on both sides. So I'll take ln of y equals ln of this monster. I don't think I put this one on the test, but let's go ahead and do it anyways. Okay, it's not going to hurt. Okay, so I simplify the heck out of the right-hand side. And first you can bring out the 1/2 power because the square root is really like a 1/2 power. So you bring that down front. Then you can split up the logarithm using the difference rule, the quotient rule of logarithms. So you'd have ln of x squared minus 81 is the same as x minus 9 times x plus 9. So I'm going to leave that there. And then minus the ln of x squared plus 81, which is a prime quadratic. You can't factor that in the real numbers. You'd have to use imaginaries. Okay. So we have ln of y equals, what do we have? And then I could break this one up using the product rule for logarithms. So I'll have 1/2 times ln of x minus 9 plus ln of x plus 9 minus ln of x squared plus 81. Okay, so ln of y will equal 1/2 times all that. Okay, now I'll take the derivative on both sides. So, implicitly. The derivative ln of y is 1 over y times y prime. This will be 1/2 times 1 over x minus 9 times the derivative of x minus 9, which is 1, plus 1/2 times 1 over x plus 9 times the derivative of x plus 9, which is 1, minus 1/2 times the derivative of ln of x squared plus 81, which is 1 all over x squared plus 81 times the derivative of x squared plus 81, which is 2x. Okay, so I'll have y prime. I'm going to have to multiply both sides by y eventually, so I'll just do that right now. And then I have a bunch of stuff, right? So I have 1/2. Let's factor that 1/2 out. So it'll be y over 2 times 1 over x minus 9 plus 1 over x plus 9 minus 2x all over x squared plus 81. Okay. You can combine these denominators. Ultimately, the thing about logarithmic differentiation, you want to get everything in terms of x. So you're going to substitute in for y. You're going to substitute this back in for y eventually. So you'll have 1/2 times the square root of x squared minus 81 all over x squared plus 81. That's what y was. And then inside here, if you combine the expressions over a common denominator, right? What do you need? Well, you need an x plus 9 times x squared plus 81 here. So that would be then plus For the second guy, you would need x minus 9 times x squared plus 81. And then the third guy, you need, it'll be minus 2x times x squared minus 81. And that would be all over x squared plus 81 times x squared minus 81, just in case you're wondering how they got the answer that you can see here in WebAssign. I would never expect you to do this on a test because it's just too involved. I would expect you to kind of just leave your answer without finding the common denominator. Just leave it in terms of x. Anyways, what do we have then? This is turning into a ridiculous problem. 1/2 square root of x squared minus 81 all over x squared plus 81 times FOIL. So we have x cubed plus 9x squared plus 81x plus 81x plus 729. Two others. Plus x cubed minus 9x squared plus 81x minus 729 minus 2x cubed plus 162 all over x squared plus 81 times x squared minus 81. Okay, so this would be 1/2 over x squared plus 81 times. Okay, so x cubes, we got 1, 2, but then that will go away. Then 9x squared is gone, so no more x squares. 81x's, something's telling me that this should be negative 81 or something. Maybe the other one was. I don't know. All right, well, I got 2 of them, so 162x's. Oh, this guy is the x. This should be an x. But that's a plus, so that would just be 4, 2, I think it's 324x, and then, oh, that's it, right? All over x squared plus 81 times x squared minus 81. And then 2 into 324. 1, 2, 6, and 2, so that would be 162x, and then you can kind of start combining like terms by subtracting exponents. So x squared minus 81 has an exponent of 1. This guy has, over here, has an exponent of 1/2. So if you bring the x squared minus 81 to the 1/2 down, you'll have x squared minus 81 to the 1 times x squared minus 81 to the 1/2, which will just leave you with x squared minus 81 to the 1 minus 1/2, which is x squared minus 81 to the 1/2. And likewise with this thing, this times this, the first power is 1/2, the second power is 1. If you add the exponents, then you get x squared plus 81 to the 3/2. And that's how they got their answer. Okay. In WebAssign. So I can see it there to the right. So again, I wouldn't expect you to do that. That's just above and beyond. You just simplify it until you get sick of it and it's in terms of x. But I'm saying I didn't put that thing on the test anyway, so don't worry about it. It's more likely I did something like this guy, number 19. Let me do number 19 just for, or it's number 75, just for completion here. Y equals x to the 8 over x. Okay. Logarithmic differentiation, ln of y equals ln of x to the 8 over x. Now you could bring this exponent down now. It should be a little easier. Okay. And then you could take the derivatives. So on the left, it'll be 1 over y times y prime. On the right, you're going to need a product rule. Okay, so I'll go leave 8x and negative 1 alone. The derivative of ln of x is 1 over x. Then plus negative 8x to the negative 2 times ln of x. Okay, so I have y prime equals y times 8x to the negative 1 times 1 over x is the same as 8 all over x squared. And then minus ln of x all over, or rather minus 8 ln of x all over x squared. And then you could replace y with its original form. So y prime is x to the 8 over x times, if you want to combine the numerators over the common denominator, not a bad idea. And that seems good enough to me. I'm looking at the answer in WebAssign, it's kind of weird. They just combine they move the x squared out. Okay. If you're wondering what they did, I would not expect you to do this. They have x to the 8 over x all over x squared times 8 minus 8 ln x, and then they subtracted exponents. So you get x to the 8 over x minus x squared times 8 minus 8 ln x, and they factored out the 8 as well. But this answer back here is probably good enough. Okay, so let's leave that section. That was enough of that. And go on to the next one. So we want to go to 3/6. Okay, and that was either inverse hyperbolics or that was related rates. I think it was the inverse hyperbolics. Okay, so 3/6, no 3/7, no 3/6. 6. Okay, so 3/6, you're looking at problems like 17 to 41. So let's see what you're up against. Let's look at 19. Yeah, so the inverse hyperbolics. You got to know those 4 main ones. I didn't put any of the arcsecant or arccosecant on there. You don't need those. It's just the arcsine, arccosine, arctan, and arccotan. Okay. Okay, so let's look at this guy. It's number 19. G of x equals 8 arc cosine of x over 8. Okay, so what do we have? G prime of x is equal to 8 all over, well, it's negative because it's cosine, arc cosine, all over the square root of 1 minus the stuff inside there, x over 8 squared, and then you have to tack on the derivative of the x over 8, which is 1 over 8. Okay, clean it up. So you got negative 1 all over the square root of 1 minus x squared over 64. Okay. If you want to get rid of those complex fractions, I always do. You'll have negative 1 all over the square root of 1 over 64 times 64 minus x squared. This will be negative 1 all over 1 over 8 times the square root of 64 minus x squared. And 1 over 8 is the same as 8, so you end up with negative 8 all over the square root of 64 minus x squared. Okay, so cosines, we also need tangent types. So this one looks like it has a product rule involved. This is number 26. H of x is x squared arc tan of 8x. Okay, so 2 product rule, and then we're going to need a chain rule on arc tan. So h prime of x, leave x squared alone. The derivative of arc tan will be 1 all over 1 plus the guts squared, 8x squared, times the derivative of the guts, which will be 8. And then plus the derivative of x squared is 2x times leave arc tan alone. Okay, so we end up with x squared, there's an 8 in there, all over 1 plus 64x squared plus 2x arc tan of 8x, like that, okay? Okay, let's see what else they got. I think that's good enough. No, there's no cosecant on there, so I'm not worried about that. That's just more of the arc sine. Now let's move on. Okay, I did 2 of them, that's good enough. So the last section I'm going to put on the test is the related rates stuff. So that's 3.7, problems like 7 to 17 odd. I'll probably throw a geometry one at you. So yeah, there is one more application. There's like 2 applications. The projectile one where you're dropping something off a building, and then a related rates problem. And again, it's probably something to do with geometry. So let's look at one of those. I don't want to do the same one I did in class. Let's look at, I don't know. Okay, let's look at this one, number 11. The radius of the circle is increasing at a rate of 8 centimeters per minute. Find the rate of change of the area when r is 38 centimeters. So that's pretty simple. The formula that relates all those variables, of course, is pi r squared. Okay. On the test, the one that I picked actually has the equation given, so don't worry about it. Implicitly differentiate, so I'll have dA over dt equals, leave pi alone, the derivative of r squared is 2r. R is supposed to be a function of t, so you also have to include the derivative of r with respect to t. They're telling you the radius, the rate of change of the radius is 8 centimeters per minute. In other words, dr with respect to dt is 8 centimeters per minute. And then they want you to find the rate of change of the area when r is 38 centimeters. Okay, so they also tell you then that r is 38 centimeters. Okay, so the rate of change of area with respect to time will be pi times 2 times 38 times 8. Okay, and it's area, so you'll have squared units. But anyways, I got to figure out what 2 times 38 times 8 is. 38 times 8 is 608 pi. And it's area, so it'll be centimeters squared, and then per minute. Okay, so that will get you there, hopefully. If you got any questions, get a hold of me. It looks like you have 2 chances to do the test, to submit it. So I think like every question, you could try it, and then if it's not right, you get one more try or something. Let me look at the student view. Maybe it'll let me look at the time limit there. Password. You got 2 hours to take the test. It's 30 questions long. And okay, so good luck, everybody. And thanks for watching the video, and we'll see you next time.